Hey guys, BuildZoid here, and this is a video in which I'll explain how to do RAM overclocking on AMD systems. So this is the system I'll be doing everything on. And let me just get the camera. So it's a Asus Sabertooth 990FX Revision 2 motherboard. I'm running two 2 gig sticks of G.Skill RAM. These are 1600 787. Rated at 1.6 volts. The CPU is an FX 9590. The heatsink is a Hyper 212 Evo. It's not properly mounted, and the two fans are just some Fantex fans. The graphics card is a HD 5850, no, 5870, and I'm using my V1000 from Cooler Master. And yeah. Oh, and there's a Samsung SSD with Windows 7 up for it. So that's a 850 that I got secondhand. There we go. So let's actually get to overclocking. There we go. So I'll just start the system up. And right now this is just, completely stock. I haven't done anything to the system. If you're wondering why the motherboard was all red, that's because it's the one I took to the LN2 overclocking event from player.net website. So they had an overclocking event, and I went to that. So, and I dipped the motherboard for the event, so that's why it's red. Right, sorry, forgot to adjust the settings on the camera so that you can actually see what I'm doing. There we go. So the thing about memory overclocking is you gotta remember that you need a pretty good motherboard for it because, bad motherboards don't play well with RAM, especially when you try to take it out of spec. Like most motherboards will do XMP, but if you're doing more than that, then you'll start having problems. So as you can see, I've just put the motherboard into DOCP. So this is an Asus motherboard. I don't know what other term other manufacturers use. Um, Obviously, your BIOS might not look like this. This is the latest BIOS for this board, so if you have this board, then you can pretty much copy everything I do. So DOCP just basically loads up the XMP settings for the RAM, so it's set to 1600. I'm just gonna hard lock all the frequencies in. I've disabled turbo core so that it doesn't mess with the benchmark scores. Set the north bridge to 2000. Actually, I think this one comes stock at 2400. It doesn't really matter, we won't be playing with that later. Disable your spread spectrums. DG plus power control, I'll just set this up to something I normally run. This isn't really important, you can set this according to your own motherboard, so yeah. I'll just set that to extreme, manual 450. Fast. There. And yeah, just max out your, so here you get your RAM settings for the Sabertooth, and I just max out the current, set the voltage frequency pretty high, and put it on extreme phase control. This basically means you have, there's no way you're going to have a power problem with the RAM, though it's not really necessary. Put your voltage control into manual mode. This CPU comes stock at like 1.48 volts or something, so I'm just going to put it to that. And Northbridge at 1.2, which is a little bit overstock, but it's to make sure that it's stable throughout all the settings I run. RAM should just boot up XMP right now, so I'll just leave that on auto. And let's see if this boots up XMP. Yep. Now there are AMD motherboards that don't support XMP settings at all. And obviously you can't just do what I did on those. You'll have to, put the settings in for that manually. Okay, so it's booting. I didn't screw anything up too badly on this first run through. Okay, yeah, it's booting. This system is a little slow to start up, even with the SSD. I mean, once it gets past this part. And I think I screwed up some of the, so how the Windows on this is set up to be basically, stripped down already. So I'm gonna have to wait a bit before everything initializes because taking longer than usual. There we go. And let's just start right off with first CPU-Z to check that, we got our RAM settings running. So as you can see here, well, as you can't see because horrible camera, uh, CPU's at 4.7 gigahertz, 1.48 volts. The memory is at 800, 1111. Yeah, so it didn't take the XMP timings. It got the frequency right, but it didn't take the timings. So right now we're at 1600, 11, 11, 11. And we'll just run some SuperPi, and we'll run the 1 million version because that'll take just a couple seconds. So I'll just let that run through and we'll get a benchmark score like that we can work with for the rest of this endeavor. So we want to improve upon this score by only changing RAM settings. I'm not going to touch the CPU frequency at all. Well, I'll try my best not to change the CPU frequency. So that took 19 seconds, 15, so 19.9, yeah. So there. I'll just keep track of the score up here. Actually, down here. There we go. So that's our current score, right? And I'll put S for stock. So that's whatever the motherboard configured on its own. And now let's go change some settings to get like this RAM to actually run XMP. There we go. So now I'll just pull the timings down to the rated settings. Oh, this is gonna be fun. There we go. Yeah, so for Asus boards, your RAM settings are this option right here that I have highlighted right now, and then we're only going to change these first four, and this last one down here. So for now, we'll keep this at 1, because that's the rated spec. And here we'll go 7, 8, 7, 24, which is the rated spec for the kit of RAM I have. And we're going to put it at 1.6, though we already picked that up. So you can already see that the motherboard picked up on the right RAM voltage. It just didn't get the memory settings, which is fine. That's not too bad. It missed the timing. So let's save and reset. So right now I've only changed timings, so now we'll get to see some. Okay, when's the mouse gonna start picking up? There we go. Benchmarks. So now let's check the timings. Yeah, again, I'm like sorry about the video quality, but there's not much I can do about it because I don't have a capture card. So yeah, so now you can see it's at 7, 8, 7, 24, 40. And we didn't change this last one, so that doesn't matter. And it doesn't do command rate for whatever reason. So now we got the right timings for the memory, and we still have dual channel here. Sometimes some motherboards will change this if one of the RAM sticks drops out. So, but generally, you don't have to worry about that. But if this says single and you're running 2 sticks of RAM, then you're doing something wrong, and you should probably, like, either you screwed up your settings and it's not perfectly stable, or you have your RAM in the wrong slots. But generally, you shouldn't have a problem with that. Northbridge frequency 2400, and the CPU still at 4.7 gigahertz. So now let's run SuperPi. Let's see if the time goes down. So Our first time was 19.5. Hopefully this time it'll be faster. I'm not actually sure how much of a difference this will make because I haven't completely checked um, anything ahead of making this video. Oh, okay, so we lost 50 seconds, which isn't that incredible, so I'll just write that time up and put it back up. So now we're doing 19.453, and that's at 7, I can't actually fit the settings, so I'll just put XMP. So yeah, there we go. So that's our new time, and let's keep going. We need to go lower. I should be able to go under 19 with just memory settings. Should be. So now that we're at XMP, you know, you get two options for what you want to do with your RAM. You either want to clock it up or you want to tighten the timings. Of these two, this is an FX 9590 CPU. Also, if you're worrying about it overheating, it's fine. You know, 37 degrees. So this is a 9590. And so with like a Phenom CPU, I can't actually go above 1600. It won't really work. But with a 9590, we can go a lot of places. These things will easily do up to 2600, and the older Bulldozer CPUs would do even 2800. But for now, let's just try boot 1800 at XMP timings. Or actually, no, I'll do... Yeah, let's just loosen up the timings. So I'll just set all the timings. And why did it lose the timing settings? Oh, well. Set all the timings to... Wait, did you CP screwing with me? Oh, that's how it does the different... Asus, you sneaky... Oh, okay. So I thought they added more memory options, but they didn't. It just changes the FSB. That's nasty. Okay, so yeah. Either way, let's just set this to 13, 13, 13, 34, which is basically as loose as you ever want to go. Anything looser is just like stupid frequency attempts. This will generally let you max out any kit of RAM, and you set your command rate as high as it'll go. 2T. 3T generally does, like, 3T is a bit of a mess occasionally. So, yeah, and let's see. So I'll put this to 1.7 volts. You don't want to go above 1.7 on AMD platforms unless you're running liquid nitrogen. Or the Bulldozer or Phenom CPUs. Phenoms can go up to 1.8, and the older Bulldozers can go 1.8 as well. They're more robust. The Viseras and like Richlands and anything newer from AMD, you want to stay at 1.7, 1.725 at most. But obviously, you know, I have the extreme setting for phase control, so it's going to voltage boost when we're running. So it's going to go slightly over 1.7, so I'm just going to set it to 1.7 right now. Timings are loose. Let's see if we can boot 1866. And let's just restart. And now I won't be going all the way into the OS because we're just checking for maximum frequency. And we know these settings are slower than the other settings I ran, so we're just going to keep trying to go up. So this booted. We still have all 4 gigs of RAM. Let's go 2133 now and see if that boots as well. And basically, we're just going to keep going up, 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 up until we hit a frequency wall. Then we're going to drop it one down and try run tight timings. That's generally the best way to quickly find like good settings. So 2133 booted. Let's see if 2400 boots. I'm just going to keep running native multipliers. This kit should be able to do 2666, but I don't know if the CPU will cooperate with that. So far, so good. 2400 is actually somewhat challenging to run on AMD CPUs. You might need to raise North Bridge voltage, CPU North Bridge voltage, this one here, to get it to work, but for now it's fine. Okay, so 2600, is that a, Yeah, okay, that's a messy one. So here's the thing. Once you try to go over 2400, you need to run your north bridge at a frequency in line with, you know, your DDR3 speed. And if I'm not mistaken, these are all just, yeah, so the maximum multiplier this actually has is 2400, and everything above that is changed FSB. So these are non-native speeds for the memory, and it's trying to push my RAM CPU too far. Okay, I'll try to just clock it into 2600 something with the CPU at like, yeah, there. That's 4.7 gigahertz CPU, and the FSB and the RAM should be happy. Yep. Yeah, so Northbridge is now at 2600, so now we need to raise Northbridge voltage. For this, I'll just punch in 1.35. You don't really want to go above that unless, of course, you have a Phenom. And we're going to keep running 1.7 volts, you know, RAM, save changes, and reset. And hopefully this will boot, but I have some doubts about that. I don't think it will. Oh, it's booting. That's surprising. So this CPU seems to be pretty good. Do we have all our settings? Yep. Yep. All the settings are running. Nope. 11, what the hell? This motherboard. This motherboard really. Okay, so it boots 2600 into the BIOS, so let's save changes and just go all the way to Windows now. This new BIOS is annoying to work with. Windows. So, you know, just getting into the BIOS is generally easier than actually booting Windows, so this might actually crash. And it didn't, so we're lucky. Now I gotta wait for the system to actually boot. And then we're gonna check CPU-Z and run SuperPi. I don't think we're gonna get a better time. There we go. So now everything is working again. So let's just check CPU-Z. And yeah, we're running 2636 Northbridge, 2600, well 1318, so 2600 uh 36 memory with 13, 13, 13, 35, 46 timings. So that's all well and good. So let's try run SuperPi now, and this should score either the same or, well, it might be slightly better because the timings are actually basically a little better. Okay, no, it's going to score worse. And again, this is not for like 24/7 stability overclocking, because overclocking your RAM really doesn't make sense for 24/7 usage, unless you're like a video editor, but even then, okay, so that's not stable enough. So I'll open up, I have AI Suite installed on this. So I'm just going to tweak some voltages and hopefully it'll start being stable after that. There we go, AI Suite 2. Run that. This did work at some point in time. Whatever, we'll just do it through the BIOS. That did work. I don't know why it's broken. It might be something to do with the RAM. Okay, so that's not fully stable. I'm just gonna give the North Bridge a smidge more voltage. And I'm gonna give the RAM a smidge more voltage. There. So yeah, I'm just not gonna go above this because I'm really not a fan of blowing up this chip's. Yeah. The problem with this like motherboard is it's running 4.75 like 4.76 instead of 4.7, which it's set to. So I'm just going to take this down a tad and see if that makes it work. The FSB on this motherboard is not the most stable thing, which is really annoying because your frequency goes up and down. Now let's try run. There we go, working. So again, just check with CPU-Z that all our settings are applied properly. So yeah, we are at 13, and now it's a 2624 instead of whatever it was before, and we're actually running 4.7 gigahertz. So that means before we were actually running above stock frequency for the CPU. So let's just try run SuperPi now, and hopefully this will work. I could have totally done a live stream of this. Holy. So yeah, we're totally going to break 19 seconds because as you can see clearly here, it's at 19.141, right? So we've just like lopped off um, a huge amount of time, and we haven't even touched CPU clocks at all. So, you know, it's like there. And now SuperPi is actually probably the most sensitive, so I'll just put the frequency 26-13. So that'll be just a like a really terrible indicator. Sorry, my English isn't that great. 2613. So that's timing. That's frequency because we're at 26 something, 2600 something. There we go. So yeah, as you can see, we basically lost 300 milliseconds by just playing with RAM settings for a bit. And you know, this is on SuperPi rankings. That's a pretty good deal. There's some other things you can do on AMD platforms to get even better times, but I'm not going to go into this because this is supposed to be a RAM timing video. Well, RAM overclocking video. So let's restart and try run lower timings. This RAM should do 10, 12, 10 or something like that. Should. It did it on a Haswell system. I never booted it into Windows all the way, so I don't know if it'll actually work. But yeah, if we can get those timings better, then it should break 19 seconds, which would be nice. So yeah, as you can see, frequency had really the biggest impact so far. So let's do 12, 12, and this timing on this RAM, this is Samsung memory, and this timing on the Samsung RAM can usually drop that timing a ton. Like you can really lower it. Like it's at 35 right now, but we should be able to go down to like 20 something. But for now, I'm not going to play with that. We're just going to go with the main timing. So I'm going to try run 12, 12, 12, 12. And let's see if it just boots. Just to BIOS. I'm not going to bother with anything more than that. It should be fine. Yeah. Okay, this is still booting. I'm just going to try crash it right now because, you know, that's the quickest way to find like the edge of your stability. Also, a lot of the SuperPi reduction could have been from the North Bridge, but, you know, that sort of goes to get hand in hand with the RAM, so that counts. Let's try 11, 11, 11. Okay, actually, I'll do 11, 12, 11, because I'm pretty sure at this point it should still work. I really don't want to lose the RAM timing, so I'm going to save a profile if this works. There we go. So that still worked. So now I'm just going to save an overclocking profile, 2611, and I'll save it to 8. Yes, there we go. So now we have our settings saved, and I don't have to worry about losing all the work I've done so far. So now we can set this to 11, and now it should crash. And it seems to have. Yep, it crashed. Let's see if it'll recover. No, it won't. So this motherboard has a convenient button which just lets you reset the RAM settings alone. If you don't have an Asus, like it's called a MemOK button, a lot of Asus motherboards have it. So if you have that, you can use that. If you're not on an Asus motherboard, you're just going to have to wipe the BIOS and use your profile, which I'll have to do anyway because MemOK basically destroys all your settings here. So let's get my profile, load from 8, yes, and as you can see, we have all our settings back, 11, 12, 11, 35. So 10, changes and reset. And this should be the limit of this RAM kit. Like, it shouldn't be able to go lower. Also, I'll show you that this RAM, not all RAM scales perfectly with voltage. And for example, this kit doesn't actually run higher voltage than 1.725. It'll crash. So once we get the timings low enough. So I'll keep tweaking it down, and at some point once I think we've reached the end of stability, I'll quickly crash it with just RAM voltage alone. So yeah, let's see if this can go down to 10. I'm not going to save another profile right now because it's not different enough. Save changes. And we're just going to keep tweaking our timings until it stops booting. And that seems to have failed. Okay, so there we go. So I just memo-keyed it again, so there. And 7. Load the profile. So as you can see, it's best at 10, 12, 11, and then I'm just going to set this to 28 because I know that's going to work. And then I'm going to crash it. If this boots up, I'm going to crash it with RAM voltage just to show you that you can't just keep pumping more and more voltage into your RAM expecting it to work. Yeah, still booting. There we go. And yep, AI tweaker. And so here's the thing. So here you can see the voltage. I'm going to just quickly set it to 1.8, and this won't boot. At least it shouldn't boot. Let's see. Oh, it's still booting. I'm going to make it not boot. Oh, whatever. Let's just go all the way to Windows at this point. And see if we can get the Super Pi time lower. And after that, I'll show you how to, like, how it doesn't scale infinitely. And I think it crashed. Nope, it's still working. No, it's not. Great. Okay, so hopefully that's because of the RAM voltage being too high, and I'll try lower that a little, and it should work just fine again. Because on the other, like, I originally tested this kit of RAM on a Haswell system, and there it just wouldn't work above 1.75 volts, so yeah. Like, it straight up wouldn't boot these timings at all, so I was expecting it to do the same here, but apparently it doesn't care as much. So start Windows. Yeah, as you can see, it's behaving much better now. Yeah, it's working. So as you can see, running the extra RAM voltage actually made it less stable. So this RAM has a sweet spot. There's some RAM that'll go up and up and up to like 2 volts or something. which is other Samsung kits, but this kit isn't like that. So yeah, let's just check with CPU-Z that everything is running properly. Close. I don't know what that is. So yeah, 10, 12, 11, 28, 2600, 1324. Good. I mean 1312. And let's run SuperPi. And hopefully at this point it should be under 19. Also, SuperPi 1 million is actually less sensitive to RAM frequency than SuperPi 32 million, but I'm not going to run 32 million because it takes a month to finish. And we're getting the same score as before. That's great. Um, okay. That's probably just 1 million being 1 million, because I bet if I ran 32, this one down here, but that takes like 12 minutes, so I'm not going to do that. Let's see. Let's see if I can somehow get it to score better. I want to lop off another 100 milliseconds, so... I wonder if we could maybe run 2700. I'm going to need a calculator for this part, because this BIOS is dumb. So the calculation for this is we're running you're not going to see anything. Oh, there you go. 12, right? So we're running 12 times 200, which is 2400. But right now we're at 20, like before we were at 18 times 12, which was the 2600 before. And now I want to do 22 times 12, which will be 2666, roughly. You know, again, the FSB on this motherboard isn't the most stable thing ever, so it's probably going to go all over the place. I'm just going to give it a tad more. That should work. And it looks like I pushed it too far. Yeah, it's not booting again. So I'll just restart the system and, well, mem-OK it and get back in. This video is really, really long. There we go. So that's mem-OK'd again. And advanced mode, load the profile. Yes. And it looks like we can't actually do anything from here. I mean, I can drop this to 28, and I can drop this to 10. Oh, right. There's still command rate. This is at 2 right now. Let's see if it'll work at 1. Should work. It's too unfortunate I can't run 32 million because I can't be bothered editing. Come on, work. Okay, yeah, that still works. Good. So that worked. Go. I want to see. There's some of the more advanced timings, like all of this stuff here, which you can, you know, try adjust for better performance. Do I trust myself to not screw this up, though? Let's see. This might be able to run 12. I'm going to try run 6. Just straight 6s like that. So slightly reduce all of them. It might be possible. I don't know. This probably won't boot because it's probably all wrong. Oh, it's still working. So let's go all the way to Windows now. But really, the thing to remember with RAM overclocking is as long as you're within the safe voltages and like, you know, you can do pretty much whatever you want. Yeah, it looks to be still stable. Stupid OS still Did it freeze? Looks like it froze. Yep, that's frozen. So it didn't like that. Yeah, but really with RAM overclocking, it's like you really can't do anything wrong. Worst case scenario, it just won't start, assuming that you don't push a ton of voltage, which is pretty much true for all overclocking. Um, and you just got to play with these settings until they work. I'm not sure. I'm just gonna set these back to auto, I guess. No, not you. You can run 28 all day. But I want to try run that one at 12, and this one should maybe do 42. Yeah, let's see. 42. A lot of the sub timings can go all over the place, and they won't really like be like black screen level crashy. They'll still boot and everything. Why didn't you boot up? Stupid computer. Yes. I'll just boot override this for whatever reason it decided not to. There we go. You unfortunately can't check like the more advanced timings on AMD systems, and that's still broken. So it looks like I ran into a wall at 2600, 10, 12, 11, and it won't go below that. See, I'll try just run this back on whatever it was before, and there. I should be able to get the command rate down to 1. That would be nice. That should still get us an improvement in SuperPi times. Though, what you got to remember is 32 million really shows much, much bigger improvements with timings than 1 million. So, if you think this like increase isn't that great, that's because I'm running 1 million. If I was running, 32, then we'd be losing quite a bit more time for every adjustment in RAM I make. And it doesn't matter, I don't need to show you the settings right now because it's not going to pick them up. 1 million, and let's roll. Please be better. Yeah, it looks like it still didn't pick up on... Yeah, okay, that got worse. So that's less stable or something. I'll try run it again to see if it won't improve, but then, like, that's just gonna mean, whatever, that running it twice. Yeah, okay, looks like it's maxed out at this point. So as you can see, overclocking RAM is generally pretty easy. Yep, okay, it's not moving anywhere. I'll just quickly show you a basic tweak you can do on AMD systems. You can do, so here are your processes, right? So you choose SuperPi, set priority high, and set affinity, and you just set it to a single core somewhere. And I'm going to set it to core 1, so this one, which means it's going to be away from, like, ideally it's going to be on its own core, and that should go a little bit faster. And now I'm going to be proven to be a complete idiot. Oh no, it's going to go faster. So yeah, this is like the most basic SuperPi tweak you can ever run. Just set the core affinity and the priority. And you can do this on any system. This works on AMD, it works on Intel. So apparently that core isn't stable. So set affinity, so 01 isn't good, 2 is not going to be good, 3 might work. That one's even less stable. 6. Please be stable. Also not stable. Damn it. Okay, well, I'll just set you to 0. 1 million. Okay. Well, now it seems like SuperPi is just completely freaking broken. Whatever. Oh well, I hope you found the video informative and at least you learned how to RAM overclock somewhat. It's not really that hard. As you could see, I was basically just like fumbling my way through some settings for the most part. Uh, and yeah, I mean, this reduction here for 1 million, like a lot of that might be from the adjustment in Northbridge speed, but you know, you can see that you can do a lot even if your like CPU cooler is completely maxed out. And SuperPi 1 million really isn't the best memory benchmark in the world. You really want to do 32 million or 4 million, but I can't use those because they take way too long to run, so yeah, and I just don't want to sit here for that long running Pi. So yeah, and that's how you do RAM overclocking on AMD if you have an Asus board. I can't show you how to do it on any other motherboard because I currently don't have any other AMD motherboards. I mean, there's that MSI board, but that's like in Prague, so I can't go use that. Yeah, and just basically it's really simple for the most part. Like you just go and you just adjust settings and they either work or they don't. There's not really any kind of super complicated way to work with this. So that's that. Thanks for watching. Subscribe, like, dislike, share it with your friends. And goodbye.